So I want to start with a quick story. So around 5 or 6 years ago, I actually attended my first conference as a web developer, a professional web developer. I had just a few months experience, mostly HTML, a little bit of CSS. But anyway, I turned up this one Saturday morning, sat in the corner most of the day and waited for a certain Mr. Harry Roberts to do what was at the time his first public speaking event. Now, this story doesn't have any relevance to the topic today, but why this is important was that first conference was the Digital Barn, and if anybody isn't aware, the Digital Barn is also a Mate-Do event. And I am extremely grateful that my first conference talk is also a Mate-Do event. The Mate-Do guys have done great stuff over the last 7 or 8 years, not just with Front End North, but with all the events that they've put on over time. So I think a huge round of applause is in order, not just for those guys, but for also our host this morning, Katie, this fantastic lineup of speakers, and also all the volunteers. So I think a huge round of applause is in order. As Katie mentioned, I'm Ben, and I work for a company named Tombola. We are a technology company based in the northeast of England, and I contribute to creating their innovative games for both the bingo and arcade platforms that we have. As with pretty much every technology company these days, we are hiring from everything through from front-end developers to marketing managers. And you may have noticed we have a stall outside, and if you are interested, either pop by there or speak to me directly. Before that, I actually worked at Sky in Leeds with what seemed like the rest of Western Yorkshire. And I've also worked for agencies who have done work for both ASOS, BlackBerry. Now, if you only had time to peek at the schedule, you may have noticed that the title maybe states that this is about React. And whilst we will touch on that to a degree, it's actually not about React specifically. What we're going to focus on today is the shift that we are seeing in the patterns we use to build our applications. When single-page applications burst onto the scene many years ago, we saw a whole host of frameworks which followed the very popular architectural pattern of MVVM. And we used the knowledge we had acquired in inheritance to create scalable applications. But like everything in the front-end land, that didn't seem to last long. We have this concept for craving what is known as a pure UI. And asynchronous programming is easier than it has ever been. So those changes have actually brought a change in the programming paradigms we use as the backbone of the project we create. Functional and reactive concepts are pretty much at the core of all the tools we rely on day-to-day as JavaScript developers. And understanding them to even the basic degree is necessary. So before I start, I mentioned program paradigm, but what do I mean by that? Well, a paradigm in the context of programming is basically a style of building programs using a collection of patterns. If we think about it from a procedural perspective, it's simply a collection of functions which encapsulate a set of steps that need to happen. Now, with that out of the way, I want to mention a few things that we need to do that are important for this. First off, try and clear your mind on how you program day-to-day. And secondly, I am by no means an expert on both of these subjects, but what I found recently from which was a quote from Crockford, which goes by, once you learn functional programming, you stop being able to teach it. I think that's hugely important to what we are trying to achieve today. If you've attempted to grasp either of these topics before, you'll know that terminology is a massive stumbling block. So you have things such as a monad is a monoid, in the category of endo functors. To people who have a solid background, that is very, very precise, and it's very descriptive, but it works. But to people who are very new to this, it's pretty off-putting, and it's a very top-heavy approach. So the aim of today is actually to provide a basis on these topics, and we're going to use concepts that I wish I had when I first attempted to tackle these subjects. So my aim today is to go from this to this. So I'm actually not going to teach you how to dance. I might do later in the bar, depends how many I've drank. But what we are going to do is we're going to dip our toe in to the water and test it. Basically, we've got two large subjects, and we need to get a platform. So let's start with functional programming. It is definitely the broader of the two topics that we're going to speak about today, but the roots of the programming paradigm are actually in mathematics. So it's pretty much a paradigm which uses principles that are older than programming itself. JavaScript has always been a pretty low barrier to entry language to come into. Most of us were probably introduced via jQuery. We then maybe played with inheritance, and that got a little bit, the barrier got a little bit higher. And then all of a sudden, we have functional reactive programming, and it seems like that barrier got exponentially higher. So functional programming, I mentioned the term, when we talked about terminology, functional programming really is buzzword city. We have things such as currying, persistent data structures, monads, endo functors. And all these topics are important if we want to climb that cliff. But everything that we need to know about functional programming to get started within JavaScript, we probably already know. It just comes down to discipline. So functional programming is all about the function. It would be pretty silly if it wasn't. So what makes a function in JavaScript? It's not a trick question. All these functions are functions. What we need to distinguish is which of these functions are functions from the perspective of the functional programmer. Functional programming is all about how data flows through our application via functions. And the three principles that we will discuss, while seeming quite basic, are proven to work due to the paradigm's roots, and when applied, should make your code more readable, reliable, and easier to test. Now I mentioned that we're going to cut out the terminology, but this is important to start with. If any of you know about imperative and declarative programming, you'll know that they are paradigms within themselves. Whilst they are paradigms, these styles contribute towards where we were and where we are going. And functional programming tries to adhere to the declarative aspect of writing code. But in a nutshell, if you don't know what they are, imperative code is basically telling the computer how to do something. And declarative programming is telling the computer what to do. The computer will work that out. In its basic form, functional programming is the paradigm for humans, I feel. Our focus from a developer's perspective is to provide a readable solution which we can trust. So the first principle we're going to discuss today is known as the pure function. So a pure function has been a favorite term in the JavaScript community ever since Redux landed a few years back. But basically peeling away the term, it's nothing more than a function that, based on its arguments that you give it, it returns the same result back every time. So based on that description, would anyone like to hazard a guess at which of these functions is considered pure? Just shout it out, don't need to put your hand up. Sorry? Line 12, or foobar. Sorry, I don't know what line it's on, so you don't have to tell us. Sorry. Yeah, so foobar, in its most basic form, is basically a pure function. If we replace the function with its return output, the application suffers no regression. What I find key to identifying pure functions is the use of the return keyword in that a function accepts parameters. So why aren't foo and bar pure functions? We mentioned the necessity for return value in arguments. So in foo's case, we take arguments, but we just log those out to the console. Bar returns a value, but bar doesn't actually control that input. So both of these are what's known as a side effect or a side cause. Foo is very much a function which encapsulates a procedure. If we think about bar, whilst this 18-line example it looks okay, let's imagine this was 1,000 lines, and we were calling bar on line 999. Functional programming is meant to be about providing readability and trust, not force the program to maintain, not force the developer to maintain the program state within their heads. We aren't good at that, but what is the computer. The problem with foo and bar are that the functional programming doesn't want us to, it's not a function from the, it's not what the functional programmer wants from us. The functional programmer tells us side effects are bad. Now, the third principle I want to discuss is composition. I know Damien touched on this, so I'm not going to spend too much time on it, but it's basically the process of combining two or more functions to produce a new function or provide some output. A necessity to understanding this for writing functional programming is the style of basically understanding the notion of first-class functions. And all you need to know here is that it's a function which can be passed as an argument, returned by another function, or assigned as a value to a variable. That is what a first-class function means. Now I'll show you 3 examples here to highlight an important point with regards to composition, and that is evaluation order. So we will read this, we will read line 1 as A, B, C, but actually we should be reading it as C, B, A. It's right to left or inside out. So you can imagine if line 1 had a few more, it was a little bit more complex, readability would suffer massively. And the problem is, unfortunately, we don't have anything to combat this natively in JavaScript. We do have a TC39 spec for the pipeline operator, but I think that's only literally just moved into draft stage very recently, so we've got a long way to go. So to accommodate for that, we'd have to write our own utilities, or we use ones such as pipe and compose. These are available via libraries such as Ramda or Low-FP, and the naming may differ. It may be reduce, write, or reduce. But they provide a cleaner solution, and most importantly, they allow you to specify how you read the execution order. Now, based on those 3 principles, you may think, if you take it to the extreme, you may think I've just ruined programming for you. So if I tell you now, if you take it to the extreme and I tell you to go and create a little application that pulls the 50 most recent tweets from the hashtag without side effects of functional programming, you're a better programmer than me, because I don't think it's possible. You can't make an XHR request, it's a side effect. So how do you do it? As I mentioned, an application without side effects is basically no longer an application, especially in JavaScript. Even in purely functional languages, they found a way around not having side effects. I mentioned at the beginning, it's all about discipline, and that is key. I may provide some basic examples for these concepts, but these are actually the underlying basis for some of the world's biggest open source projects today. I mentioned the pure UI at the start. In the notion of a DOM component from React uses the concept of pure functions. It returns JSX with data passed in as arguments. Side effects have to exist to do anything useful, as I said, but if you scatter them everywhere, you can't trust anything. Redux batches all of its side effects off to the highest branch. And why? Well, if they have a bug, they're probably going to say, well, it relates to that specific function. They know that a lot of their stuff it works because it's testable, because it's pure. All of their side effects is probably where the bug exists. Now we've looked at 3 basic but extremely important concepts of functional programming. If you apply them correctly, they will get you pretty far. But let's move on now to looking at reactive programming. Now, reactive programming used to scare me. I'm not afraid to say that. It's the smaller topic of the two, and I definitely found it the most daunting to grasp. But on my journey, I sort of found a foothold to climb in that cliff, which I constantly use to work as a way to work my way up, and I hope that I can share that with you today. I was exposed to reactive programming via RxJS, or reactive extensions, which is a library from Microsoft. Because of this, it actually led me to believe that reactive programming was RxJS specifically. Now, it's safe to say the opposite, definitely. RxJS is reactive programming, but the opposite doesn't. It's not. You can't say that it's just reactive programming. It's just RxJS. RxJS provides an abstraction over a certain way of doing reactive programming, similar to how Ramdo is with functional programming. The abstraction it attempts to create is to introduce us to a new type known as an observable. And when I started with RxJS, I obviously thought, well, an observable is reactive programming, so that's why I sort of got a little bit lost. But reactive programming doesn't actually require the concept of a stream or an observable type. It's basically about coordinating concurrency. But to understand reactive programming, I feel that we have to peel back the observable. Now, this section is going to be less code and more theory. And we're also going to throw in a cheesy example to help. I want to introduce you to the style of reactive programming RxJS introduces for 3 reasons. Whilst the TC39 spec for the observable is still in draft form, I would hazard a guess and say because of Rx's popularity, we will see it added to the language at some point in the future. As I said, understanding the underlying concepts of an observable flipped the switch for me on the paradigm. And thirdly, most importantly, we get to open a little pizza shop. Now, some time ago, a book was written known as Design Patterns by a group of people referred to as the Gang of 4. In this book, the diagram above was contained to show a relationship between design patterns they had spoke about. And I've highlighted the observer in the iterator pattern here, because as we'll find out, these 2 patterns are very similar. They're very important to understanding reactive programming, but weirdly, no relationship was ever formed. Now, as I said, we're going to do a little example, and I'm going to need Katie for this, so I apologize. It's only a predefined request, it's fine. But before we start that anyway, I'm going to actually go over both the iterator and the observer pattern quickly. So whilst they are different, the main thing that you'll notice when we go over it is that they are both about consuming data progressively, but where they differ is in the sense of who controls the flow of data. With the iterator pattern, it's all about the consumer controlling the flow of data. And when you actually call what is known as an iterable, you get an iterator object back, which returns a next method. An iterator provides a way, it's really good for traversing a collection asynchronously, basically, progressively. Calling next will provide you metadata about the values, such as the current value, if an error occurred, or if that collection is complete. If we had 3 items in the iterator, for example, if I could request each of them at my own pace, and that is known as a pull-based API, the consumer is in control. And we have many of these examples in the front end at the moment, but one of them that you might be familiar with is this pull-based strategy is similar to what React uses in its different algorithm, along with should component update. Now, the observer is very similar, except the control goes to the producer. You can think about the observer pattern as basically just an event listener in JavaScript. That's what it's driven by. It will pass down events to the consumer when it receives them, and it's pretty much a fire and forget API. It has no unified contract. It's also known as a push API. In that push strategy, we have many of those as well, but you can liken it to Vue.js's getters and setters. Weirdly though, we have no way of knowing if data is complete, or if an error occurred within the observer pattern. So if we do this example, we are going to share pizzas around the audience. I am going to make the pizzas, pass them on to Katie. Katie's going to cut them up and pass them around. We haven't got any pizzas, obviously. Let's not be stupid. So basically, all I need from Katie is Katie to ask for the next pizza. You've came up with something, so you don't have to come up. You can just sit there. It's fine. Just shout up. It's fine. Just can I have the next pizza? I'll pass it on to you. No, just say can I have the next pizza? I should have been more clear. This is just can I have the next pizza? That's all you've said. No, that's me saying, that's all you need to say to me. This is really bad. So all you need to say to me is, can I have the next pizza? You cut it up. Of course, we got there in the end. You cut it up, pass it around. We obviously haven't got anything, but I'm waiting for you. Again, we come on, so it's the same thing again. I pass it on. Of course. Okay, so you get the point, but basically now we've run out of pizzas. I'm not made of money. But the problem is, I'm not in control. Katie has to actually has to ask me for the next pizza. I know I'm out of pizzas, but it's Katie's in control of the data. Of course, I'll pass down the metadata and say we're done. And that's me and you finished. Yeah. Anyway, because this example got really bad, now I'm in control. So basically, it's a case of, I apologize for this, Katie, in advance, but I'm in control. Katie doesn't, so it's basically me just throwing pizzas at you now. I'm just going to throw pizzas at you. And the difference is that I'm in control of the data, but Katie doesn't know if that flow of data is finished, and I have no way of letting her know there's an error or if that data flow is finished. So it could have been pizzas, anything, but you are always looking over your shoulder to see if I'm throwing another pizza at you. It's up to you to buffer those. That example didn't work, but yeah, you get the point. So now, if we merge those two patterns together, basically the result is what they're trying to achieve with, with the observable. We have so many different interfaces to combat our async issues in the past, such as async await, generators, promises, callbacks, etc. If we had recognized the link between these two patterns earlier, event handlers may have ended up with 3 signals instead of 1. And we may have had a single unified API with a lot of semantics we had requested out of the box before now. Learning reactive programming through RxJS provided little clarity for me. That confusing terminology, ridiculous documentation, and the mountains of operators actually meant that I was oblivious to the paradigm and I was lost in their API. Understanding the architecture of the observable meant all I had to know to progress was the concept of pushing and pulling. So we've been through the two paradigms that I want to introduce you to, but why are these important? Why are they important to us as developers today, and how will they impact our careers? Now, I mentioned earlier we should try and clear our minds, and if you did, hopefully that now makes sense. If you're like me, muscle memory on how you program on a daily basis becomes a blocker, and you struggle to understand how you incorporate especially these learnings into your everyday work. You don't see it as a separate thing. You may have noticed that observables are similar to event emitters. Composition is a bit like inheritance, and you block out those things as they don't provide anything new. If you had an open mind and sort of forget what you know for a minute, you'll find these concepts provide an alternative way to tackle challenges. And with a little bit more depth, they actually might be better for the things that you were doing. It's understandable to be skeptical, but I advise that you give it a try because you'll be surprised of how much of a difference these little things can make. Secondly, why this is important is front-end development is, particularly in JavaScript today, is crazy. It's a crazy area at the moment. We work in an industry that is of constant change, and it usually becomes the case that you are just about getting the hang of library X, and then library Y comes along, and that's no longer hipster or important anymore. But both functional and reactive programming within JavaScript are growing exponentially, and that growth definitely isn't stopping. The nature of the applications that we are writing today means that these paradigms are heavily suited for what we need, what we've discussed today. And libraries and frameworks are spewing into the ecosystem at a rapid pace with these principles at their core. We all came here to learn more about the industry we work in, and whilst it is only prediction from me, I feel the understanding of these principles to even just a basic degree will be vitally important as a front-end developer in 2018 and beyond. Now, before I wrap up, I want to show my thanks to the people on screen. My journey was made a lot easier because of these guys and the resources that they provide. An exhaustive collection of resources that are available via articles, talks, and workshops, and these guys tackle the hardest problems in the easiest way. So if you wanted to delve deeper, if any of us wanted to delve deeper into any of the stuff we have just looked at today, I definitely advise that we look up any of these guys. As I mentioned, the focus of today was to provide a platform, a stable architecture which wasn't so top-heavy and is relatable in some way. But most importantly, it's an attempt to change the way we think. Promoting a change in the mindset will no doubt make us better developers, as we'll have more tools in our arsenal to approach the challenges we attempt to fix. So whether you choose to stick with the roots that we focused on today, or we maybe go and try and create some branches and apply for our membership cards to Functional Programming Club, we'll definitely be better developers for it. Thank you.